Hello there, welcome back to the Techno Innovation Hub. So it's going to be the second session on Oracle architectural explanation. Let me share the screen. So we have been discussing this one, actually the approach that we are going to take for our discussion on architectural journey. So that is what we were discussing on the last session. So let's continue. So this is the next topic, actually, the very first starting slide on architecture. So the Oracle database server. So I have given a definition. Of course, this is extracted from one of the references I have given earlier. So Oracle database server, an Oracle database consists of at least one database instance and one database. One database instance and one database. So you might be confused what is being told there, but the definition is there in Oracle documentation as well as in the technical reference as well. So we need to get an idea about this one. Very simple. An Oracle database consists of at least one database instance. So it is a one-to-one relationship. In a standalone environment, unless it is a cluster, one database always deals with one instance, one-to-one relationship. One database always deals with one instance. And normally in the instance, we are referring to as the logical set of components. Instance is something volatile, it's not permanent, it is in RAM, random access memory, right, normally. So it is a set of memory structures and background processors, so that is instance. When it comes to the database mostly represents the physical structure. That means an Oracle database consists of mainly three file types. Those are control file, log file, and DBF file. So let's go on to the explanation towards visually. So database server we have the database instance, that is what I mentioned, one database. Within that database server means database instance and Oracle database. So this is what the definition says actually, right? Instance and Oracle database. So I told you one database always deals with one instance. That's what. So this is the link between the memory and the physical. Now the downside, this side is a physical. Those are the disk components. Data file, log file, control file are in disk, right? But here the top part, instance, those are in memory, random access memory, instantaneous, volatile, right? As far as the memory is up, as far as the instance is up, it will be there. But if due to some power failure or something and some crash happens, it is gone, permanent. It's not permanent, volatile, right? Now this is permanent, it's the disk. So database instance. So at a very high level, we can say database instance consists of system global area or shared global area and set of background processes. So normally we can say STA is equal, instance is equal STA plus BGP. I think we have learned this one in our CP series, CP1 and CP2. In the document also these things were explained. We are just kind of revising here. And further, we have this client applications, right, to connect to the database. They have to connect. So server process is there, which is one of the background processes. We know whenever client want to connect to the database, what's going to happen? Client side, there will be some kind of application, some kind of a front end at a very basic level, maybe SQL plus command line, or maybe whatever front end GUI, maybe SQL developer, maybe Visual Studio, right? Maybe VS Code, maybe whatever, right? We can tell IntelliJ or whatever the front end is there as the client application. So whenever the connection is initiated means he may type in the username, password, and the last thing is connect string. The third step is connection. Connect string will tell where to connect. Connect string means what? It will indicate where is the database, what is the name, IP address, which protocol, and likewise. So in the user end, client application end, those information will be provided, which will cause something called a user process to start here. So then user process will be sending depending on the information. Now in the connect string, we have those information. We'll come to in more detail, but I'm just very high level telling here. So depending on the IP address and the server name given, it will send the information towards that IP address. So then comes the server process. Server process means what? It is coming in the, later in the verification. Initially, what will happen? This information will be sent to the Oracle database, right? And because there's a listener process in between. So listener has to detect that one, and it has to talk to the Oracle server, and it has to verify the information. So likewise, there are set of steps are going here. So anyway, ultimately, if the user information is verified and if the connection is successful, then what will happen? A session will get started. Right? And the session will get started. So then what will happen? If it is a dedicated connection that the user is requesting, definitely dedicated server process will continue to be there as far as the session available. So don't worry, I'm just telling very high level. So this is we have the database server here, and we have the database instance here. So database server means this instance plus the database. That is what it says, right? So that is what we have to capture here. Oracle database consists of a database instance plus a Oracle database, physical, logical, and physical. And we have HCA within the instance, and we have background processes, and this is client server connection, because external users have to connect to the Oracle database now. So that is what you need to understand from this picture. Fine. Let's continue. Oh yeah, program global area also there, right? So that is program global area. PGA is another component again within the instance program global area. Now SGA is shared, no, SGA known as shared. This will be shared across multiple users, but PGA is dedicated. It is not shared. It is, each server process will have its own PGA, plus each background process also will have its own PGA. So let's learn those in later program global area. And here is not indicated the user global area also there comes into play, but those things will be explained later. Let's continue, and up next. So this is how we are going to continue the explanation again. Memory structures. So we are going to discuss initially about system global area or shared global area, collection of memory structures that we know the definition by now. And having a detailed explanation on this, after that we will be going to explain, we will be explaining program global area, PGA. Then comes the user global area, UGA. So these are mainly finally the software code area, that is also some memory area. So let's discuss those things initially in great detail under memory structures. So for the explanatory purposes, I have taken memory structures separately, SGA, PGA, and UGA, and software codes. Then the process structure separately. So memory structure and the process structure, or we can say memory architecture and process architecture, whatever, doesn't matter. So basic process architecture, we have the client process, which I just explained earlier, client user process and the server process, and we have the server processes. Right, server process, and we have the background process mainly. So likewise, for explanatory purposes, we can categorize these areas. Each area is a big explanation. So in the upcoming slides, we can dig into more detail. So in this slide, we better not get into more detail itself, so that can cause some confusions. So let's start with the next slide. That's the best. So here now we are going to start with the, as the previous slide says, system global layer. So let's try to get an idea about SGA, and from here we'll be learning background processes as well, background processes. Okay, so memory structure we are going to touch upon detail SGA, and for the basic process architecture we are going to learn background process as well. Now, at the very first thing, startup command, we have seen this, the startup command. What is the very first thing to do to start a database? So just let's revise it, right, for you to get an idea. So let's get to our Oracle database instance. Okay, we have it now. Now you can see it is shut down. I have shut it down. Let's use the 19C instance for this, because most of the explanations are based on 19C. and is shut down at the moment. So let's start up. So this is what happens. Startup command. Just to revise, just to remind you the things. Startup command. The very first thing what's going to happen. The very first thing is you saw now you saw instant startup. That's the very first thing. You will start the instance, then it is a mounted. Finally, it is a open. So these are the main three stages in startup. But we know this one. We have seen this. But what we haven't understood yet, what's happening behind with instance is starting in detail. Again, we have explained a little bit of detail, but now we are going to see in great detail with the architecture. Now you can see here, some information is available, total SGA area, right? And fixed SGA, fixed SGA, variable size, database buffers, redo buffers. So likewise, there are some basic information available. So let's try to get into this information and try to understand one by one. And finally, you can see database mounted is there and database open. So that is, those are the latter stages. We will learn it once we understand, once we understood the instant startup part. Okay, so let me switch back to presentation. Now, what it says initially, on the other slide, says instant started. So this is what's going to happen when the instant started. Database instance is there, and what are you going to have? You're going to have SGA, system global area. That is what's going to happen. You saw that instant started means on the behind, these components are going to get created. It will be done by Oracle server. So what are the components? Mainly the SGA. SGA means another name, memory structures, MMS. So what are the memory structures? Actually, MMS plus background process. So it's going to, the first thing is the SGA, then the background process also will get started as soon as the instance is up. So these two are mainly be their background process. So on SGA, what are memory structures? And we are going to have actually a program global area also been indicated in this particular instance. That's okay. Let it be for the time being. PG also will get started depending on the program process. That's okay. Leave PGA for the time being. And what are the memory structures we are going to have? Shared pool, one of the major, because there are compulsory memory structures as well as optional memory structures. So a shared pool is a compulsory one. And within that, we are going to have mainly library cache and dictionary cache. So later we will dig into shared pool separately and try to understand the components within that. There are other components other than library cache and dictionary cache. So what is given here are the most important ones only. So let's talk that one in later detail. Now this is the first round of instance explanation. Component wise, memory structure wise, we are going to drill down later again. Let's try to get the definitions here. Now let's see. Again, we are going to have database buffer cache. Now these all are memory structures. Instant starting means on the back end, these things are automatically getting started. That's what. And again, we are going to have optional extension. Optional extension, that is database smart flash cache. Of course, this I think a 12C feature is continuing with enhancement in 19C and 21C as well. Let's try to get the understanding definitions later. I'll just show you the components initially, and after that we are going to have redo log buffer. Redo log buffer is a circular buffer. That's why I have indicated like this. Let's try to understand more detail. Circular buffer is log buffer, and then comes fixed SGA, and after that we have now these are compulsory actually. These shared pool must be there. Database buffer cache must, redo must, fixed SGA anyway is going to be there, and these are optional. In memory area, mem optimized pool, flashback buffer, Java pool, large pool. Within the large pool, we are going to have user global area depending on the shared server configuration. And because if it is a dedicated server, this UGA component also may be there in the shared pool. But if it is a shared server, UGA is going to sit on large pool. and request queue, response queue, again those are for shared server, and we are going to have more optional areas, shared IO pool, streams pool, likewise. So those are the main components, I mean compulsory ones and optional ones within this SGA. Then comes the background processes. You can see the first background process, SMON, system monitor, and you are going to have process monitor. These are compulsory background processes. It is a must to have those things in order to instance be up and running. And you are going to have DB writer background process, database writer, and you are going to have checkpoint background process, and again log writer background process is there, and you are going to have process manager background process, and listener registration background process will be there, and likewise we have MMNL, memory manager, and likewise and we will have recovery background. So don't worry, these things are compulsory actually. In 19C, you are going to have these things up and running as soon as the instance is up. So let's understand these things little by little in detail. Here I am just showing you the components only. I'm not going to give the, at least the definitions are not given yet, but I just want to see the components first, get familiar with these terminologies. That's what I want to do in this slide, but I'll be coming back to this slide and I'll be giving definition for each and every one, what is the purpose as well. Right? So let's continue, and then the PGA component, because PGA also within the instance, but it is not in SGA. SGA is a total separate thing. We know that now. This is another memory structure. Okay. So you saw it here in the previous explanation. PGA is another memory structure. So within PGA, now this is shared, this is not shared, this is unique. Within PGA, we are going to have small memory areas like SQL work area, private SQL work area, session memory, likewise, PGA. And further, server process also there, because each server process is going to have a separate PGA, and server process will be communicating with database buffer cache, with log, likewise. I tell you one example, because whenever user needs some data to be fetched to the memory, that means, okay, now let's say user is executing a select command. Select employee number name from, let's say, EMP table. Now this need fetching data from this, no? So server process is responsible to read that data from the disk and store in the database buffer cache. And if a DML command happens, the particular update will trigger a change, a modification. That modification will be updated in the redo log buffer. Again, server process will be doing that. Server process belongs to that session, right? Because in a dedicated server environment, each user is going to have a separate server process. So that particular server, let's say if the user is ABC, so ABC server process belongs to user ABC. So that particular server process will be responsible for requests coming from that particular user. Okay, so like we'll understand those in more detail. So again, each server process is going to have dedicated PGAs. Fine. So that's just to give you an idea. Just to give you an idea. So let's come back and get into more detail about the definitions of each and every memory area. So very slowly we will go. So I'm not going to continue right away in this session. I'll come back to the next session and give you definitions for each and every memory structure. All right, I'll see you soon. Have a great time. Bye-bye.